Okay, so hello and welcome back. So in the previous video we basically derived all of these formulas, and basically there is a whole bunch of formulas that we will have to derive in these few videos, but they are absolutely necessary for you to be able to work in trigonometry. Okay, so now of course these formulas must be committed to memory. And of course these are part of some formulas that we are going to prove right now, and these of course must be also committed to memory. And there is now a couple of formulas that are usually used in trigonometry very extensively, and that is basically using basically, if you have a unit circle here, my pen is not, if you have a unit circle here, so you see that over here you have 0 and 2 pi radians. Here you have pi by 2, here you have pi, and here you have 3 pi by 2. So there is usually all of these formulas that are used in trigonometry. For example, pi by 2, for example, you want to know what is the sine of pi by 2 plus some other angle, pi by 2 plus some angle x, and this happens to be, for example, the cos of x. For example, what is, for example, the cos of pi by 2 plus some other angle, and that is equal to, for example, negative sine x, and so on and so forth, right? So there is pi by 2, then there is pi, and for pi you can say that, for example, what is the sine of pi, for example, minus x? What is the sine of pi plus x? Because you can go in this direction, you can go in this direction as well. Or you can say, what is the cos of pi minus x? What is the cos of pi plus x? And all the other trigonometric ratios related to in terms of pi. And so if I say that pi by 2 minus x, I would end up somewhere in the first or second quadrant. Pi plus x would be some angle in the third or the fourth quadrant, right? Usually, I have not seen 3 pi by 2 in these formulas. They're typically not used in trigonometry, at least not in these lines of books that I have, that we are using as our text here. Meaning, usually in the Indian education system, even when you go to college, you don't express your angles in terms of 3 pi by 2, and I don't really know what the reason for that is. That might be a convention or something. And so then there is also 2 pi. So of course some angle can be expressed in terms of 2 pi. For example, you might need to know what is the sine of, for example, 2 pi minus x, or what is the cos of 2 pi minus x, and so on and so forth. So all of these formulas we will be able to derive here using the formulas that we derived in the previous video, which is basically, we said that the sine of x plus y is equal to sine x cos y plus cos x sine y. We also said that the sine of x minus y is equal to sine x cos y minus cos x sine y. We also said that the cos of x plus y is equal to cos x cos y minus sin x sin y. We also said that the cos of x minus y is equal to cos x cos y plus sin x sin y. We can use these formulas in order to derive all of those formulas that we talked about. So let's start with pi by 2. So for example, you want to know what is the sign of pi by 2 plus x. So basically you can use this formula here and set x is equal to pi by 2, y is equal to x, right? And so you will have the sine of pi by 2 cos x plus the cos pi by 2 sine x. Sine pi by 2 is equal to 1, so that this whole thing becomes cos x. Cos pi by 2 is equal to 0, so this whole thing becomes 0. So this is equal to cos x. Now, what is now the cos of pi by 2 plus x? The cos of pi by 2 plus x, you can use this formula and write it as the cos of pi by 2 cos x minus sine pi by 2 sine x. And you know that the cos of pi by 2 is equal to 0, so this whole thing goes to 0. Sine pi by 2 is equal to 1, so that's negative sine pi by 2. Now next what you have here is for example the tan of pi by 2 plus x, which is equal to the sine of pi by 2 plus x over the cos of pi by 2 over the cos of pi by 2 plus x. So the sine of pi by 2 plus x is equal to cos x. The cos of pi by 2 plus x is equal to negative sine x. Cos by sine is equal to cos, so that's negative cot x. The next thing that we have is the cot of pi by 2 plus x. The cot of pi by 2 plus x is equal to the cos of pi by 2 plus x over the sine of pi by 2 plus x, which is equal to, again, the cos of pi by 2 plus x is equal to negative sine, actually this is supposed to be negative sine x. Negative sine x, so that's negative sine x, and sine of pi by 2 plus x is equal to cos x. Sine by cos is equal to tan, so that's negative tan x. Now, what is the secant of pi by 2 plus x? The secant of pi by 2 plus x is equal to 1 over cos of pi by 2 plus x, which is equal to 1 over negative sine of x, which is equal to negative cosecant x. And what is the cosecant of pi by 2 plus x? The cosecant of pi by 2 plus x is equal to 1 over sine of pi by 2 plus x. Sine of pi by 2 plus x is equal to cos x, 1 over cos x, which is equal to secant x. So that is all the angles that you will need. That is all the identities in terms of pi by 2 that you are going to need for all the 6 trigonometric ratios. Now the next angle that we will cover is pi minus x is pi minus x. Now what is basically what is the sign of pi minus x? So we said that basically sine of x plus y is equal to sine x cos y plus cos x sine y. Cos x sine y. And if you have a negative here, you will get a negative here. Also, we said that the cos of x plus y is equal to cos x cos y minus sine x sine y. And if you get a negative here, you'll get a positive here. So then the sine of pi minus x is equal to basically sine x cos y, that is sine pi cos x, and minus cos pi sine x. Now sine pi is equal to 0, so this whole thing goes to 0, and cos pi is equal to negative 1, so negative 1 times negative 1 is equal to positive 1, so this is equal to sine x. What is the cos of pi minus x? The cos of pi minus x is equal to cos pi cos x plus sine pi sine x. And cos pi is equal to negative 1, so that's negative cos x. Sine pi is equal to 0, so this whole thing goes to 0. What is the tan of pi minus x? The tan of pi minus x is equal to basically sine pi minus x over cos pi minus x, which is equal to sine x over negative cos x, and that is equal to sine over cos equal to negative tan x. Now there is a couple of things that you will be able to see in these formulas, and then we will talk about them once we want to summarize them, right? Okay, so then what is the cot of pi minus x? The cot of pi minus x is equal to basically the cos of pi minus x, over the sine of pi minus x, which is equal to cos of pi minus x is equal to negative cos x. Sine of pi minus x is equal to sine x. And so that is equal to negative sine by cos is equal to negative cot x. What is the secant of pi minus x? It's equal to 1 over cos pi minus x, and that is equal to cos pi minus x is equal to negative cos x, which is equal to negative basically secant x. And what is the cosecant of pi minus x? That is equal to 1 over sine pi minus x, which is equal to sine pi minus x is equal to sine x, so that is equal to cosecant x. So that is all the angles related to pi minus x, right? Or all the trigonometric ratios in terms of pi minus x. Then we have also pi plus x. And again, we said that the sine of x plus y is equal to sine x cos y plus cos x sine y. Negative, negative here. And we said that cos of x plus y is equal to cos x cos y minus sine x sine y. And basically negative positive here. Now, what is sine of x plus sine of pi plus x? Sine of pi plus x is equal to sine pi cos x, sine pi cos x plus cos pi sine x. Now sine pi is equal to 0, so this whole thing becomes 0. Cos pi is equal to negative 1, so that's negative sine x. What is the cos of pi plus x? The cos of pi plus x is equal to cos pi cos x, and minus sine pi sine x, minus sine pi sine x. So now cos pi is equal to negative 1, so this becomes negative cos x, and sine pi is equal to 0, so this whole thing goes to 0. Now the next thing that we have is what is tan of pi plus x? Tan of pi plus x is equal to sine of pi plus x over the cos of pi plus x. Now the sine of pi plus x is equal to negative sine x, and the cos of pi plus x is equal to negative cos x, and you will get basically tan x. Negative and negative will be cancelled out. What is the cot of pi plus x? The cot of pi plus x is equal to the cos of pi plus x over the sine of pi plus x, which is equal to cos of pi plus x is equal to negative cos x is equal to negative cos x, sine of pi plus x is equal to negative sine x, and then you will get basically cot x. What is the secant of pi plus x? The secant of pi plus x is equal to 1 over cos of pi plus x. So cos of pi plus x is equal to negative cos x, so that's 1 over negative cos x, and that is equal to negative secant x. What is the cosecant of pi plus x? It is 1 over sine pi plus x. 1 over sine pi plus x. Sine pi plus x is equal to negative sine x, which is equal to negative cosecant x, which is negative cosecant x. So this is basically pi plus x. And the next thing that we have is 2 pi minus x. That's the last set of formulas here. We have basically 2 pi minus x. So again, basically we have sine of x plus y is equal to sine x cos y plus cos x sine y, and negative, and we have cos of x plus y is equal to cos x cos y minus sine x sine y, and negative positive, right? Now, what is the sine of 2 pi minus x? What is the sine of 2 pi minus x? It's equal to sine 2 pi cos x minus basically cos 2 pi sine x. Now sine 2 pi is equal to 0, so this whole thing goes to 0. Cos 2 pi is equal to 1, so that's negative sine x. Negative sine x. What is the cos of 2 pi minus x? The cos of 2 pi minus x is equal to cos 2 pi cos x plus sine 2 pi sine x. Now cos 2 pi is equal to 1, so that is equal to cos x, and sine 2 pi is equal to 0, so this whole thing goes to 0. What is the tan of 2 pi minus x? The tan of 2 pi minus x is equal to the sine of 2 pi minus x over the cos of 2 pi minus x, and that is equal to, basically, sine of 2 pi minus x is equal to negative sine x, and cos of 2 pi minus x is equal to cos x, so that's negative tan x. What is the cot of 2 pi minus x? The cot of 2 pi minus x is equal to cos of 2 pi minus x over the sine of 2 pi minus x, which is equal to, so cos of 2 pi minus x is equal to cos x, that is equal to cos x, and sine of 2 pi minus x is equal to negative sine x. So that is basically negative cot x. What is the secant of 2 pi minus x? The secant of 2 pi minus x is equal to 1 over cos of 2 pi minus x, and cos of 2 pi minus x is equal to cos x, which is equal to secant x. What is the cosecant of 2 pi minus x? That is equal to 1 over sine of 2 pi minus x, which is equal to negative sine x here. Negative sine x, which is equal to negative cosecant x. And that is all the formulas that we need for basically for these basically related to all of these angles related to pi, pi by 2, 2 pi, and so on and so forth, for all the 6 trigonometric ratios. Now let's do a summary of these. So what I'm going to do is write them down all somewhere. For example, on Paint, probably. Okay. So starting from the top, we said that sine of pi by 2 plus x, sine of pi by 2 plus x is equal to cos x. The cos of pi by 2 plus x, pi by 2 plus x, is equal to negative sine x. And then we said that tan of pi by 2 plus x, tan of pi by 2 plus x is equal to negative cot x, negative cot x. We said that cot of pi by 2 plus x, cot of pi by 2 plus x is equal to negative tan x. And we said that the secant of pi by 2 plus x is equal to negative cosecant x, negative cosecant x. And we said that the cosecant of pi by 2 plus x is equal to secant x. Right? So that is one part here. So you can see that. So that is cos x negative sine x negative cot negative tan negative cosecant and secant. So you can see that when you have pi by 2, sine is turned into cos is turned into sine, tan is turned into cot is turned into tan, secant is turned into cosecant, and cosecant is turned into secant. Moreover, only in the case of sine and cosecant, and you know that basically sine x is equal to 1 over cosecant x and cosecant x is equal to 1 over sine x, only in the case of sine and cosecant, the right hand side of this formula is positive. In all the other cases, the right hand side is negative. So again, 2 points there are here to remember, in order to be able to remember these formulas properly, because you will forget them, right? And these will help you immensely. Number 1, when you have pi by 2, sine is turned into cos is turned into sine, tan is turned into cot to tan, secant to cosecant, cosecant to secant. And all of the on the right hand side you will always get a negative sign, except for the case of sine and cosecant. So that's basically the first part. Now the second part is about pi minus x. It's about pi, or to be more exact, pi minus x. So we said that basically the sine of pi minus x is equal to sine x. We said that the cos of pi minus x is equal to negative cos x. We said that the tan of pi minus x is equal to negative tan x. We said that the cot of pi minus x is equal to negative cot x. We said that the secant of pi minus x is equal to negative secant x. And we said that the cosecant of pi minus x is equal to cosecant x. Right? So what that means is that basically when you have pi, sine remains sine, cos remains cos, tan remains tan, but cot remains cot, secant remains secant, and cosecant remains cosecant. In all of these cases, so sine, basically you have sine, negative cos, negative tan, negative cot, negative secant, and cosecant. And again, in all of these cases on the right hand side, you are getting a negative sign, except in the case of sine and cosecant. So that way you can remember them. But you need to remember that in the case of pi, basically there is no change between the trigonometric ratios. The trigonometric ratios remain the same. Whereas in the case of pi by 2, the trigonometric ratios were changed to their counterpart, meaning that sine and cos and sine, tan and cot, and secant and cosecant, right? So the third part of this formula is again related to pi, but this time we have pi plus x. So we said that, for example, the sine of pi plus x, then we had the cos of pi plus x, then we had the tan of pi plus x, then we had the cot of pi plus x, then we have the basically the secant of pi plus x, then we have the cosecant of pi plus x. So the sine of pi plus x is equal to negative sine x. Negative sine x. The cos of pi plus x is equal to negative cos x. The tan of pi plus x is equal to tan x. The cot of pi plus x is equal to cot x. The secant of pi plus x is equal to negative secant x. And the cosecant of pi plus x is equal to negative cosecant x. So as you can see, in all of these formulas, again I have pi here, and there is no change in the trigonometric ratios, meaning that sine remains sine, cos, cos, tan, tan, cot, cot, secant, secant, cosecant, cosecant. And in all of these, basically, and this is pi plus x, in all of these cases you will get a negative sign on the right hand side, except for the case of tan and cot, which are the inverses of one another. Except in the case of tan and cot, all the other trigonometric ratios are negative, right? And the third part, the fourth part and the last part that we had here was the sign of basically 2 pi minus x. Then we had the cos of 2 pi minus x. Then we had the sine cos the tan of 2 pi minus x. Then we had the cot of 2 pi minus x. Then we had the secant of 2 pi minus x. And then we had the cosecant of 2 pi minus x. And this is equal to basically sine of 2 pi minus x is equal to negative sine x. Cos of 2 pi minus x is equal to cos x. Tan of 2 pi minus x is equal to negative tan x. Negative tan x. Cot of 2 pi minus x is equal to negative cot x. Secant of 2 pi minus x is equal to secant x. Cosecant of 2 pi minus x is equal to negative cosecant x. And again here you can see that in all of these cases, when you have 2 pi, sine remains sine, cos remains cos, tan remains tan, cot, secant, secant, cosecant, cosecant. And basically all of these trigonometric ratios are negative, except in the case of cos and secant. And of course, it's easy to see the reason why that happens, but we would have to go into the unit circle and see why that happens. The why is not that important, really. There is a reason you can draw a unit circle and see what really happens in the unit circle. And as a result of that, basically, all of these sign changes happen in these formulas. But as you can see, basically, only when you have pi by 2, the trigonometric ratios are converted into their counterparts, and in all the other cases they remain the same. When you have pi by 2, basically all of the trigonometric ratios are negative except for cos and secant. When you have pi minus x, then again all of them are negative except for sine and cosecant. when you have pi plus x, basically all are negative except for tan and cot. And when you have 2 pi minus x, all are negative except for cos and secant. So you can somehow, if you want to remember, so basically there is basically 2 points over here. So let me first make a screenshot here, and then you can easily create some sort of mnemonic. Mnemonic are very popular among students usually. So if I call this trigonometric ratios or trigonometric identities part 2, for example. Okay. So what you can do here is that, so first of all, the change in the trigonometric ratios themselves, that's easy to remember, that only when you have pi by 2, the trigonometric ratios are changed. Except for that, there is no change in the trigonometric ratios. You can categorize them as case number 1, case number 2, case number 3, and case number 4, so that you have some way to remember them. But of course, the problem with this mnemonic is that whenever you need any one of these trigonometric ratios, you will need to produce the whole table. Otherwise, it wouldn't work really. I mean, the way that I'm creating this mnemonic right now. So in the first case, you can see that in the case of basically sine and cosecant, and you need to pay attention to how I'm creating this mnemonic. In the case of sine and cosecant, on the right hand side you have a positive. On the right hand side you have a positive. So I take this as a sine, and so the first case, I take this as the sine, and so you automatically know that the inverse of sine is cosecant, so you can remember the cosecant as well. In the second case, again, you have basically the same story, meaning that all of these are negative except in the case of sine and cosecant. So again, you have the sine over here. In the third case, you have, in all of these cases, you have a negative here, except in the case of tan and cot, right? So I write tan, and so I automatically know that cot is also there because cot is the inverse of tan. And in the fourth case, you have the positive happens in case of cos and secant. So that means that I have cos and secant, so C. So that means that now I can get rid of these numbers, and I can simply remember this as SSTC. SSTC. And what I can do with this is that now, now I can basically come over here and create my table all over again. It would be very simple. So I have SSTC. So what that means is that, for example, I have basically, this is related to case 1, this is related to case 2, this is related to case 3, this is related to case 4. And you don't even need to produce the whole table. You can create the part of the table that you need. And I know that, for example, case 1 is pi by 2 plus x. I know that case 2 is basically pi minus x. I know that case 3 is pi plus x, and I know that case 4 is 2 pi minus x, right? So now suppose I need a trigonometric ratio related to pi plus x. So I can simply write all of the trigonometric ratios related to pi plus x, which is sine of pi plus x and cos of pi plus x, right? Or for example, the tan of pi plus, I don't even need to write all of these. I could suppose that I need only this one, right? So I know that the cos of pi plus x, we said that in the third case, which is since I'm working with pi plus x here, so then I have to refer to the third case. And in the third case, we said that tan and cot are positive. That means that cos is negative. So I will get a negative sign here. And, well, of course, since I'm not working with pi by 2, this is not going to change. So I'll get the same trigonometric ratio and sign over here. And that gives me basically the exact trigonometric ratios that we were looking for. Cos of pi by 2 plus cos of pi plus x is equal to negative cos x, as you can see here. Now suppose that I need, for example, I don't know, tan of, for example, 2 pi, for example, minus x. So how do I do it? So I know that basically, first of all, in the fourth case here, this is the fourth case, basically, of course, the trigonometric ratio itself is not going to change. So I'm going to get a tan here. And here cos and secant are positive. So tan is negative. So tan is negative here. And so then I get the x here, which means that tan of 2 pi minus x is simply equal to tan of 2 pi minus x is equal to negative tan x, as you can see. So that way you can just simply remember this by remembering SSTC. SSTC, S stands for SSTC. S stands for sine and cosecant. The second stands for sine and cosecant. The third T stands for tan and cot. And the C stands for cos and secant. And that means that these are all, these are positive, these are positive, these are positive, and these are positive. And that way you can remember everything. So it's pretty simple, really. Now, I'm going to end this video here. There's a whole bunch of formulas that you need to learn, really. We will go through them in the next videos. I'll see you in the next videos, and thank you.